We're back. Got the live streaming stuff working again, I think. So this will be recorded so you can watch afterwards. Where we're at, I believe, is that we should be here in kind of ready for lesson 5, looking at second part of exponentials, looking at some applications. And then what we have, this is Wednesday. Next Monday we'll do a review of 4 and 5 with a practice test. I think I may have one in Canvas. If not, we'll so let's take a look at that, and then we'll come back and look at the lessons. I hate we're relying on the Wi-Fi at this point because I can't get into the wired, so it might be a little bit slower.
The network has been slow all day. If you want to.
Okay, so it's which may cause problems for the live stream, but the live stream's also being recorded on my hard drive, so I can re-upload it if there's transmission problems. We'll just deal with all the technical issues. Let's see, so this is our course. If we come into the modules, that's usually where I put everything. Hopefully I still have them here. Let's see if you have access. Okay, so that was 1 through 3. There's resources, calculator day, lesson 4 and 5. So actually I do have a practice test on exponentials here under lesson 5. And then there's a practice exam for exponentials where there's even a key, test key in here. So exponential worksheet revised, that probably sounds like it might be newer. So these are the types of things. I'll send these out through, well, they're here, but I'll also send them out in an announcement to, these would be good things to start working on. We'll use them as review next week. So there's this, and then show you the other part. Quadratics, here we are, exponentials. The other one, this one, is another good review. Again, there'll be some solving problems, or solving equations. These we'll do graphically. You graph one side and the other. We'll take a look at a few of these type of problems. These we were doing on Monday, finding the vertical intercept. Remember, that's just really the number in front. So as you go through these, when you actually know what the answers is, it's really just looking, the answers are right there. Okay, so this is what we were doing. And then these questions are dealing with the rate. So it's basically taking the base and subtracting 1 from the base to figure out what the rate of change is. So we were doing problems like this, so we could look, this is a 17% growth. Okay, so those were what we were doing yesterday. And then these are some more solving, just graph both sides, but that's what we'll be working on today. And then some more questions on the vertical intercept, and that's about it. So again, take a look at these. I'll have some printed versions of them first to work on. Good. Yeah, print them off, work on them, and there's an answer key in there. But that's the test questions will come from that. Perfect. Oh, good. And the answer key, I've even drawn some graphs and helped you go through those. So those are there. Okay. So what I want to do is go ahead and take a look over internet being so slow, this is probably not a good thing to do, but I'll just show you what's here. There's a YouTube video. Has anyone seen the movie Pay It Forward? Awesome. So there's a clip from the movie Pay It Forward about Trevor's idea, helping two people, paying it forward, helping two people. It's actually a great lesson in exponential growth. So it's there. I'll let you watch it on your own, maybe when you have a better internet access. But, you know, it's Trevor showing his idea, and yes, it's exponential. Okay, so that's, well, I guess I have to go back. So that's there in MathAS. It's one of the links. So if you go there, it takes you right into the YouTube thing. And I think it's a good thing to highlight. Okay. So what we're going to look at, let's see if this is working. Here we go. Maybe it'll work. There we go. Okay. So we're going to take a look at characteristics of exponential functions, growth and decay rates, which we've kind of been taking a look at, some models, and then, you know what? Maybe I shouldn't do this, but I'm going to. This whole section on doubling and half-life you'll probably see it again in a chemistry class because they, you know, exponential rates of decay. They use that for radioactive decay and such. There won't be any of that on the test, okay? And I don't think there's any on the final. But what we'll do is don't worry about that part. We'll go get the first part mastered, and maybe after the test I'll explain it, because it's one of those things, once you understand the other part of exponential, it's really just, it's a simple thing. But if we try to throw it in now, it's just one more thing that adds to confusion. That's what I found. But it's really an easy thing to understand once you've mastered the other ones. But trying to throw everything in on one day or you know, before spring break. But we'll take a look at those when we come back from spring break, just as a couple, basically to get us back from, when we get back from spring break. Let's do that. Because the schedule was Monday we'll do a review of practice tests, practice test type questions, and then Wednesday we'll take the test. Remember, you do get a page of notes, front and back, so whatever you need, they can be examples, anything you want. I'm not going to collect it, not even going to look at it. Put whatever you want on it, whatever you need. Okay. But part of the process is if you do take the time to organize a page of notes, a lot of times you don't need to use it, but it's that process of organizing. So that first time I just was open notes because it was so much stuff. This content is just 2 sections. It should be fairly narrow. You should be able to get everything you need onto one page, front and back. And I always throw out a little bit. Did I limit the size of the page? I didn't. So take that loophole. Never said what size. So I had to have people bring like the Dead Sea Scrolls and roll it up. Whatever you need to do. But again, 1 page should do you. It could be a big poster size, whatever you want to do. But if you need it, do it. But I think 1 page will do you. Okay. And again, the process of doing, don't just take somebody else's notes. Oh, these are good. They gotta be good for you, unless you've practiced with them. And again, try to do them early so that you use your notes while you're doing practice tests and stuff, so you know what needs to be there and what maybe you're missing. Okay, so let's take a look. Oops, where am I? That's the weird thing of this. Let's see. There I am. Okay. Again, there won't be any questions about domain and range. We did talk a little bit about them. You will see that again in 150. Just remember the domain is everything. It's all real numbers. We can put anything into an exponential. And how about the range? What kind of numbers do we not get as y values when we have exponentials? We don't get anything below sea level. We don't get any negatives. So, and we don't get 0 either. That's good. We won't get 0. What y equals 0 is not going to be one of us. It's all positive values. It's bigger than 0. Okay. But again, that's not going to be on the test. But as we look at graphs, that's what we're going to see. Remember the vertical intercept? That's going to be the starting value. We'll see that in the equation itself. There is no horizontal intercept because y is never equal to 0. So that we don't worry about. So I like to just kind of go through and just, anything we don't really need to know about, it's really just to get in the way, all of these concepts, because there is no horizontal intercept. But again, we'll talk about those when it's important, and some of the other stuff we'll be doing, we'll come back and pick them up. But for exponentials, we don't need to worry about those. And again, the horizontal asymptote is always, oops, what happened there? It's always y equals 0. Again, since it never changes, why talk so much about it? But you'll see that's, the x-axis is the horizontal asymptote. So that's about all we'll really talk about. But when we've got this example up here, looking at this, can anyone tell me what is the vertical intercept? Because that is a question I'm going to be asking. It's the starting point, and it's 0 because x is always 0. So that's the one thing when you're looking for a vertical intercept, always have x has to be 0. If it's not a vertical intercept. On a multiple choice test, that could throw you off. And then what's the second part? Someone said it? 132. It's this number in front, right? If you put in 0 for x, this becomes 1. 1 times 132 is still 132. So as you saw, I think on the actual test I have maybe 6 of these questions. There's either 3 or 6. But it's just a matter of coming and saying, there it is right there. That's your answer every time. That's the y value when x is 0. So get used to just picking that number from the front.
1.18 is the base.
Good. So then, let's see, what does it ask? Where does it ask? Function increasing or decreasing. So that's kind of where we're getting. Yes, the other part of this whole thing is the base. And what we do with the base see if I can watch here. We turn it to a percentage by multiplying by 100. So we like to think of it as 118%. 118%. But remember, with every problem, what percentage do we always start with? 100. Whatever it is, if we have 25, that's 100%. Whatever we have, that's 100% of what we have. It's 100%. So everything's based on 100% of whatever we started with. So that's why with these ones, when we want to talk about increasing or decreasing, we come and we subtract off what we started with, which is 100%. And then whatever's left, in this case it's a positive 18, so that's an 18% increase. So it's like percentage-wise, we're adding on 18% each time. So we would say, well, this is increasing, and we'll say by 18%. Okay, that's the other kind of important half of the test. Just that alone, those two things, finding the vertical intercept and then being able to say whether we're increasing or decreasing by how much, that's the key part. You'll be just fine. and then we'll have a few questions where we'll use the graphing calculator to find intersections and solve them that way. And I'll work through some. And also, since we've missed out on having a couple of videos, I will go back this weekend. I'm trying to make time, being sick and then all this other stuff. It's a lot of work in life, isn't there? You guys know that. You're working, but we try it. We'll be okay. Okay. That's why I don't like due dates. If we're too stressed out, we need to push something off. Let's do that. We have actually got extra time. Okay. We've got at least 1 or 2 extra weeks we can play with. We can make it 3 weeks if we need. So we'll be fine. I'd rather you get it this first time through, one way or another. And if not, that we circle back and we, if it didn't work the first time, let's try something else until we get it all to work. Okay, so those are the two things, and then what we do is we're going to graph them, and then we're going to solve things graphically. And I think the other thing we'll do today is we'll do one question on exponential regression, and again, I'll do a video on that. But if you did well on the linear regression, it's really the same thing with with a different button press when you go to the calculate. So I do still have that video out there on linear regression, and again, I'll post some more of my own on here, because I know if you go through the media lessons, there's a lot of stuff in there, isn't there? A lot. And I like to get to the shortcuts. Let's just get things done. Let's get the down and dirty, and then maybe look at some more details if you need to. Okay, so far so good. So what did it do? Let's get that going. Let's just kind of keep going. Okay, and again, I sort of taught this in maybe reverse order, but this is exactly what we've been doing. The only thing I would change on this is where you see this B is the base. I would think of it as the base. I like to think in terms of percentages, so I go with, instead of 1, I go with 100% plus R as a percentage. Okay. Again, you can use these. Go ahead and use 1 and then use R as a decimal. But I bet you, at least if you're like me, you'll find that thinking in terms of percentages is going to be easier. So that's the way I'm going to go through this. But notice it does connect back to this. With this 1, all I'm doing is saying that's 100%. This R, I'm going to say that's R percent. So instead of having, like if it was 25%, I'm going to use the number 25 instead of 0.25. Okay. And I think if you'll go through it, if you're not struggling and you're good with decimals and stuff, that's fine. You'll be, I won't cause you problems. But if you have difficulties with decimals, this could be the solution. Okay. So there's two processes. There's, if we know the rate, we add 100% to it to get to the base. But if we know the base, what we do is, okay, now I'm in the right place. So to get the rate, and we've been doing this, the rate, and again, I like to work with it as a percentage, is equal to the base as a percentage, right? Put that minus 100%. So that's what we've been doing. So we'll work through some of these, but I'm just being very open that I'm going to do them as percentages, and so I use 100 instead of 1. You're welcome to use 1 if you want. They're really the same thing. It's just 1, you have to work with decimals, and I believe it's a little harder to do when you use 100%. The arithmetic's just a little bit easier. Okay, so that's what I'm going to do. And notice, when we've got the rate, in either of these cases, we always just, and I'm even going to do this one. I would say this, I disagree with this. It's sort of right, but it's actually sort of wrong. If we do the same formula, all that happens is because, remember, if we have a decay, the base is going to be less than 1. What we end up with is we end up with a negative rate, a negative number. Doesn't that make sense? If we're decaying, we have a negative rate. I think it makes more sense. So instead of trying to remember these two, which messes things up, well, do I subtract 100 from the base, or do I take the base from 100? I just do it this way all the time. If I get a negative number, that's a decay. If it's a positive number, it's an increase. It makes it more clear. So this is another place where I disagree with how it's presented, but this is how most textbooks would present it. But it's why most of us don't understand it either. It's just too difficult. I mean, it's just too much, and it's not really, we don't really gain anything. So instead of looking at these, we'll just go with the rate is the base minus 100. So you'll see as we go through these problems down here, and these are the types we're going to work through on the test. Yeah, we'll go through all of these. All we have to do is when we have the base, we subtract 100 and we get the rate. If we have the rate, we add it to 100, and that gives us our base. And again, if the rate is a decrease, we think of it as a negative rate, so it's 100 minus it. So it's always 100 plus the rate. It's just when it's a decrease, the rate we look at, we put in a negative number. So again, it gives us just two things. We have 100 plus the rate, if we're looking for the base. If we've got the base, we take the base minus 100. That's what we will always do. If you do this, you'll be like me. You'll need years of therapy to recover from it, and then to finally understand it after too many times. And then you'll find, oh, this is the way to understand it. It's clear. It's just two different processes, right? So those are the two we want to look at rather than what they have up here. And again, yeah, whether I'm adding the rate or subtracting, I just get so many questions of it. And when I used to teach it this way, it was so hard to explain. And now I said, don't think about that. Think of a decreasing as a negative rate. Think as an increase as a positive rate. And then just follow these two formulas, and you'll never go wrong. You'll always be right. Okay, so take a quick picture of that. Think. Oops. And then we'll take a look at a few examples here. Okay, so, and again, we're a little bit ahead of the game, so we're going to just take a look at these formulas, just from looking at it. How do I know whether it's growth or decay? Where do I look? So I look here. What's that?
There's no negative number, so it's less than 100.
It's less than 1. So yeah, there won't be any negative number. So this is where sort of at the beginning. So it's a number less than 1. We will get a negative rate when we subtract it from 100 or subtract 100 from it, right? So we'll see that. So this one we're just going to, by looking at it, base is less than 1, so decay. Okay. It's asking for the initial value. Where do we get that? Starting value, 812. And again, it doesn't want the vertical intercept, it just wants the initial value. That's 812. Okay. When it asks for the intercept, then we'll list it as 0, 12, or 812. Sorry. So that's just the number in front, or the number that we're multiplying by. That's our initial value. So far, so good. part of this is, yeah, we'll graph these and we'll verify these when we start solving them, but that's kind of what we need. So what's the growth or decay factor? What do they want by the factor? What is a factor? And they say in math, a factor, what are they telling us to do? Multiply. The factor means multiply. What are we multiplying by? 0.71. That's exactly what we put here. This is the factor that we're repeatedly multiplying by. So as a factor, we list that as 0.71. So it's another way of saying that's just the base. Okay.
And what do we do with that? Is it 2 that have the x, like 0 point, comma, then the x?
Where,
Is that the exponent where the x is above the?
here?
That one, yeah.
Yeah. That's the exponent. We don't really deal with it, but that's where we put our input until we go to use it. But at this point, we're just looking at the number parts because those numbers give us characteristics of this as far as increasing, decreasing, and initial value. And then the variable, we plug in different things to get different inputs, get different outputs. Okay. So growth decay rate R. So now what is the rate? Now remember, this is one where they have you use, you're always going to be, so we've got the base, right? This is what we call the base. Or they also call it the factor. So what I do for the rate is I take it times 100, because I like to work with percentages. And again, you might sort of skip this step, but just 0.71 is going to be 71%, right? And the thing I do a little bit differently than what the book does is then I'm going to subtract 100%. I don't care whether it's increasing or decreasing. Every time I have the base, I just subtract 100%, because that's what I started with. So when I take 71% minus 100%, what do I get?
29.
Negative 29. Now when we report it as a rate, MathAS wants it as a positive value. So yes, it's just going to be 29%. And since I've already identified that it's a decay rate here, that takes care of the negative. Okay, so that's the only other thing you have to say. Yes, it is physically negative 29%. I just report it as a 29% decay. Maybe I'll write that word here. So that's how I incorporate the negative, as I call it decay. If it was positive, I would have called it growth. And then, oh, they want it as a decimal and a percent. That's, I see. Well, so I do it this part first, I guess. I get the 29%. And then all I got to remember is here, turn it back into a percent decimal, right? Divide by 100. It's going to be 0.29. So I put 0.29. Just erase my percentage there. So. And I don't need the percentages. So they have you do both, and again, on the test, I'll accept pretty much either one. Just telling you with decay, I think I prefer to have the percentages, 29% decrease. The only time we need the decimal is when we need the factor, when we need the base. So we've already got that. So the rest is to report back to the world, what is it? 29% decrease. We don't say 0.29 decrease, because we don't use that. We only use the 29%. Okay, so far so good? Okay. So let's do another example, and then maybe we'll jump into this other one that gives us some other values. Let's go with green. So growth or decay here? Growth. Very good, because the base is greater than 1. Growth. Initial value? 64.5. Good. And again, if they wanted the vertical intercept, we would just list that as 0, 64.5. But that's where it comes from. Either case, it's just that number in front. It's just right there. The answer's staring us in the face. How about our growth or decay factor? Remember, this is really just asking what is the base. 1.32. Okay, and again, I'll do this a little bit. They wanted the growth or decay rate as a percent. So I take the 1.32, multiply it by 100 to turn it to a percentage. So I think of it as 132%. And then remember, I always subtract off 100% because that's what we started with. So what is happening? We are growing by 32%. And then I can turn the 32% into a decimal, move it back, and it's going to be 0.32. So, and again, you'll find your way. You know, you might just look at these and the answers pop out to you. You write them down. That's fine. You can't really see what's going on in my mind. At least I hope not, because it's a mess up there. But so I show you what I'm thinking. But again, you may get to the point, and hopefully you do. You just start to look at them, and you're just picking these out and writing them down. That's fine. Okay. So far, so good. Okay. Again, the test, we're going to do both of them. We're going to go back and forth. I ask about the starting value, initial value, and about the rate, and as a percent, and growth, and all that kind of stuff. So let's take a look at this one here where we have to kind of go backwards. And this one's a little tricky. So we're given, if we look at this, we're given that it is growth, so that's important. We're given an initial value, and we're given the growth rate as a percent. Okay, so let's kind of work backwards from this. So what do I do when I have the rate? How do I get to the base? Do you remember, what do I do? So if I have the base, when I have the base, what do I do to it to get to the rate? I subtract 100. So when I have this, if I'm going backwards, what do I have to do? Add 100. Good. I have to add 100. Now, if this was a decrease, I would put a negative on this. So all I got to do is I got to take this percent, add 100% to it. So when I've got the rate, and I'll just do that down here. Now watch, this is where some people are going to maybe have problems. That 0.5%, that's not 5%, that's not 50%, that's less than 1%, right? Because I've got it as a percentage already. So what kind of a growth rate is that? Or that would be as I work towards getting back to my base, that's going to be 100.5%. Okay, and then I can use that if I divide this by 100, right? Turning the percentage into a decimal, I can come and say my base actually is going to be 1.005. And what's my rate as a decimal? Take this divided by 100, it's going to be 0.005. Questions there? Did that throw anybody?
A little bit.
It should have. It throws me all the time.
What did you do to get the 0.005?
So what I did is, to get this, I took 0.5%. Better erase that. Give me some more room. To get this one, I take what they gave me as 0.5% and I divide it by 100. Because whenever I have a percentage, if I divide a percentage by 100, I get the decimal. And I plug in my calculator because it doesn't feel quite right, but what it does is it moves the decimal to the left 2 places, so that's how I get the 0.005. But I like to use a calculator because it's easier. I see it, and it just doesn't feel right for some reason, but it is. Okay, it's these parts of a percent. Okay, and so now we're all set. We've got our initial value. We've got our growth factor, right? Adding 100 to 0.5%. So what is our function going to look like? We'll call it h of t. What do I put in the front? I take my initial value, 8.24, and the factor part goes into parentheses, 1.005, and then I give it an exponent, and since I'm using t, I'll put a t for my exponent. Okay, so that's, you know, if you, these are good practice because you're going backwards and forwards, and remember the only difference is in one way we subtract 100, the other one we add 100, and you just have to remember which way we're going. If we have the rate, we add 100 to the rate to get to the factor. If we have the factor, or the base, we subtract 100 from it to get back to the rate. Okay, so it's just, and that's the easy way to do it. Don't look at the book, it'll confuse you because they've got 4 different formulas to do it, and then you got to think, is it increasing, just don't even.
Go over that again when you said what you subtract 100 from.
Okay.
Your
So
growing and decay.
when we have the base, when they give us the base, that's when we're going to subtract 100 to get to the rate. And so that's the formula they gave us for that. So what I said, we got the base, we want the rate. That's when they gave us this formula that we're looking for the rate is equal to the base minus 100%. And again, I do 100 instead of 1. Okay. When we've got the rate and we're going to the base, what we do is, again, it focuses on we're looking for the base. We're going to take our rate and we're going to add 100%. Okay, so we always take our rate, add 100%. We've got the base. If that's what we got, we subtract 100%. Those are the only 2 things we need to do. And again, watching the videos, they show you 4 different ways and 4 different situations, and this smooths it out. This is all you have to worry about. If you do this and then you look at the other videos, you'll kind of say, oh, that's all they're really doing anyway. But it's more than just semantics. It does, like I said, I learned the traditional way, and again, it took me years to really understand it. And had to go through some unlearning to say there's a lot easier way to look at this. And all I can say is that math is one of those areas where the people who do math are people who are usually wealthy because they don't have to do anything else. And it's, most mathematicians throughout history, through the Western Civ at least, have been people that were just, you know, wealthy and didn't need to do too much. But yet math is also, and not just Western Civ. You look at the Aztecs and the Mayans, even in a lot of cultures where they set up empires, there would be a class that would do math, oftentimes the priests. And because with math you could calculate when the eclipse was going to come, and that was a source of power. And even if it was a simple calculation, you didn't want the ordinary people to know that it was a math calculation, because they would know that it was just something that was going to happen and you calculated it. It made a lot more impact if you said, we're making the gods angry and I'm going to have them turn out that sun until you do what I say and give me millions of dollars. I gave them power. So they didn't want you to have the power of doing it yourself. And I believe this is trickled down into math education, even though we say we want to, and I believe people who say they want everybody to learn, they believe it, but even myself, I've had to unlearn things to say there's easier ways to teach things. And I believe what we've got is the leftover of the colonial era that was really trying to make math difficult to learn, because they wanted to say it's your fault you can't learn it. You're not smart enough. That's what they wanted to do with the math. Well, I think it was a lot of teachers either weren't smart enough to figure out an easier way to explain it, or they actually at some point in history were trying to make it hard. because they didn't want people to succeed. So my goal is to make it easy for you so that you can succeed, and then we can change the world that way. Just like Trevor, 2 people at a time, right? So watch that, pay it forward. Just help 2 people. Okay, so far so good? Does that make sense? Okay, so I'm going to save this page. Let's call this page 3. And I guess I don't have to clear out. If I go this, it gives me a new page. And let's see if there's anything more. There's another one. You want to do this one? It's a little... Actually, we better. Just so that this one should go fairly quick if we've understood what we're doing. Okay, we'll do that. So what that gives me is I remember to turn a percentage into a decimal, I divide by 100. So my factor is going to be 0.8. Okay, 0.80 if you want. Over here, they want the rate as a decimal. I could go with 0.2 here. Again, I don't really use this much. Their methods, they use it, so that's why this is really, for me, an extra step. To turn the rate into a decimal is like, I don't care if you do it or not. So I'll just cross it off. Okay. But this is the thing we need, is we need the base as a decimal. And that allows us to write the equation either in function notation or just like y equals, what do I write first? 150, that's our starting value, our initial. And what do I multiply by? 0.8. And then x is the exponent that just goes up here. There we are, just like that. And again, you just need to practice this. This has both sides of the test question in there, initial values. If I give you a percentage, you can make the equation. And then we can use that equation if we need to. Okay. That's the basis of everything we're going to be doing. And then the last part is using the calculator. Once we have these things set up, being able to use the calculator to solve these type of problems. Sure.
So you flipped it and you added the 100
Yes.
if you're given the rate
Yes.
as opposed to.
What they're showing.
So do you ever flip it the other way where you minus the 100? Like if you're given the factor?
Right, when they give us the factor, that's when we subtract the. So I always put what I'm given first, and then when it's the rate they give me, I add 100. When it's the base they give me, I subtract 100.
Okay.
But I always put the 100 second, which is not something the book does. But to me, being dyslexic, I need that. If you do one thing left to right and the other thing right to left, I am thrown off really hard. Okay, it's hard to recover from that. So I try to do everything in one order if I can. And it creates a little, it's different than sometimes how they show it. And again, maybe down the road, there might be a reason for why they're doing it that way. But a lot of it centers in on whether this is a positive or negative. And a lot of times they just want to say it's 20% decay. They don't put the negative on it. I like to just put the negative because that, to me, signifies decrease. And it works. That's the way to work. Okay. And then I don't have to switch whether I'm adding 100 to this, or if I'm adding this to 100, or if I'm taking 100 from this, or do I take that from it's just too many different things, and it throws you off. But this one, you just take what you're given, and you're either going to add 100. You'll add 100 if it's the rate that you have, rate plus 100. You'll subtract 100 if it's the base that you have. So it just depends on one of those two things. Okay, good. Now, let's see. And then they've got some worked examples, and again, those are good to just maybe sit and look through because they're already worked out. And just so you can see, and then maybe cover up part of it. Okay, if I had this, what would I get? Well, I had 100, so it should be 104.8. Oh, there it is, 1.048. So, you know, maybe cover up certain parts, come back, and try them at different times. So, you know, you can test yourself on one way, kind of like a flashcard thing. Okay, and I find a lot of, for me at least, learning, if you see the right answers a lot of times, it'll help because then you can focus on the process rather than trying to get an answer. Oftentimes in math we focus too much on trying to get an answer and we forget about really trying to focus on the process. When we've got all the answers, then this is where we can come back and focus on the process. And you can say, okay, if I have the base, how do I get over here? Turn it into 104.8, subtract 100. Oh, there I am, the 4.8. Have this, I subtract 100 to get here. If I have this, I add 100 to get there. And you know, a few times doing it, and you'll find your way of organizing it. And then you'll put it on your note sheet, and that will solidify it for you. That's really what the note sheet's for, is to make your learning solid and burnt in. But you don't want to burn it in until you got it right. Too many times I'll go too fast and I'll burn in the wrong process and then, oh no, I gotta learn that. But it's burnt in, right? Oh, sorry. So, okay. And then again, some more practice. It's good to go through these, you know, print these out or they're in the workbook if you've got it, or just, you know, sit down and write them out. But go through a few of these and you should get to the place where you pick up some speed. And the problem is when you're first learning math, it's slow and it takes time. And you'll do one or two, and then I spent so much time on those, I don't want to spend any more time, I want to move on. That's actually the time where you want to say, no, let me do some more of these. That's when you'll start to pick up the speed. And that's when once you do pick up the speed, then you know you're picking up the learning. And it's not about going fast. It could still be a little bit slower than someone. It's not comparing to others, but just watch yourself. As you pick up a little bit more speed, a little bit more confidence, then that's where it's going to happen for you. And again, this is a U try, so the answers are in there for that as well, so you could look those up. Let's see, should we go through? Yes.
So when we get the rate, we add 100.
When we have the rate and we want to get the base, we add 100. Yes. When we have the rate.
I'm confused with the previous one. Did we add 100 with the 20 and 100% when we got 80%?
Yes, we added 100, but we made the rate negative because the rate was a decay. So that's the trick. We're always going to add 100, but if it's a decay, we put the negative on the rate. That's where it belongs. And I think that's where I differ from the book in my approach, is I always put the negative on the rate so that I'm always adding 100.
But it was 80. It wasn't, I confused because it was like 20. If we had 100, it would have been like 120. But it was 80.
Right, because we put a negative. This is not positive 20. This is negative 20. Right? In fact, let's see if I can go back. Oh, good. I'm almost there. Yeah. See, I just maybe need to go. There we go. So what I did is I put the negative on the 20. See? So it's negative 20 plus 100. But I got the process is always going to be add 100. And that I can live with. That I can remember. Always add 100. And then just remember, put a negative on decays. Positives on increase. So yes, if it was an increase, it would have been 20 plus 100 is 120. Good. And then I get used to it. Oh, it's over 1, it's an increase. And then I check, oh, it was supposed to be a decay. Okay. So that's a natural way to do it. But this, yeah, then that way I don't have to worry about changing the process that I'm doing. Okay. It's 2 o'clock. We're doing okay. Got through those. Let's do the U try because the other one's let's do this one, and then I want to get a little bit into the calculator. I'll also let me ask you this. Let me ask you, what part of the calculator? Let's see, where am I? Let me do this. Leave myself some notes before I go on to that, because I find sometimes it's easier to do the calculator sort of as a separate one. As you've been working through the calculator, what are you struggling with? What are any parts of it that is more difficult than the others? Or is it all difficult? Or so what's going on here? Okay.
For me, the part when you get to see all the values for x and all the values to y, but that, I think, is that a table?
It's a table. Okay, so that's, yeah, usually there's some issues with tables, and I can show you, and again, I'll do a little video that's just sort of how to adjust the table to do it, because there's table set, and there's a couple different settings. So I will do a special video just on, if you're looking at tables, yes.
On the windows, when you're setting your windows for your calculations, do you have a standard that you start with and then you can go from there?
Yes. The standard is a Zoom 6. So I would say, and that's just because that's what the calculator starts with. And if you look at Zoom 6, it's a Zoom standard. Standard, one more D, right? So I use Zoom 6 because that automatically fits it. And what it does is it makes this standard window something like this, where this is -10, this is +10, this is -10, and this is +10. And again, this right-hand side, this is your X maximum. And again, I'll go through a video that will walk you through kind of how to do these. And this -10 here, this is your X minimum. This -10 here, this is your Y minimum. And the +10 is your Y maximum. So again, I will start here because a lot of times, a lot of the questions they initially give us will be there. And then you look at things like, what's my initial value? Well, if my initial value is 1,500, I better move my Y max up. That's going to affect the Y values. If I'm looking for where a solution is, sometimes if the X value is more than 10, I'm going to have to move that out as well. But there's also sometimes where if we move out or zoom out too much, we won't see what's happening, so we have to zoom in. So we have to go with both things. And that's typically what I find is the two issues are setting the table, getting the table, the table of values, X, Y. The calculator will give us this stuff, and these are sometimes very powerful. This table oftentimes help us to figure out what type of window to set. So I will tie these two together. I'll show you how to use the table and a couple different features of the table, and then I'll show you how that helps with setting the window. But those are the things you just kind of have to practice.
When you're giving us a cheat sheet on that, are you going to go ahead and modify the inputs for the calculations, like press Y, Z, and then just make them more useful to us? Because I forget the second, when you say second calc, sometimes I forget to put that in and it messes up. Sometimes I forget all the processes of putting in.
Right. What I try to do is get you so that you get used to not looking at an answer or a step-by-step thing, but looking at the keyboard itself and identifying where those buttons are, okay? And that each button has 3 options. And so if it's blue and above, I got to hit the blue key to, so I have to shift to make the key do that. And I believe if you get on that, if you get doing it that way, you just remember it's the calc thing, but the calc is above the button, so I have to hit the second first, rather than trying to remember exactly the key press sequence. Because yes, if you hit it wrong. So I'll try to walk through there. It will print it out. I mean, the calculator thing I use has the step-by-step as well. But I think, yeah, these are the two areas. And because then what we do from here is we're going to graph something that might look something like this. And then when we're solving something, usually we put in what it's equal to, and that looks like this. And where our answer is right there at the intersection. If we find that intersection, we've got our answer. And the calculator will tell us what that x value is. We're looking for the x value. It will also give us the y value, but let's say x equals 3 when y equals 5. If that's what we're looking for, is we solved for x right here. So we're going to do it graphically, a lot of the stuff we're going to do. Okay. But we have to be able to do that. So we have to be able to plug into y equals. That's usually not too bad. We'll take a look at that. But then the thing is to be able to see this. If it's in the standard window, fine. But if we have to zoom out, that's where the difficulties can be. But we'll do a few where we won't have to do too much zooming. We'll do some. And then also I'll show you there's a few features like something called, let's see, there's Zoom 6. There's also Zoom, I'm not sure which number it is, but if you look for Zoom Fit, that's also a valuable one because oftentimes it automatically will try to fit the graph into a window. Yes?
It's Zoom 0.
Zoom 0. So it's got a 0 in front of it.
What about Zoom 9? I think that's not
Zoom Stat, we use that when we enter the data. And so we're going to use that also because we'll be doing some regression. So that's perfect because it looks for the data. But if we don't put in data, if we don't go to stat and L1, L2, it won't help. But it does help if we put in data. Good. So that's another good zoom. So Zoom Fit, number 0. Zoom 9, which is a Zoom Stat. That's helpful when we got data in there. And then Zoom 6 just gets us back to the start. If we get lost, I always come back to Zoom 6 because that'll, it's a good starting point. And then we either make it bigger or smaller from there. Okay. Let's take a picture of that. So I'll do sort of a calculator video that will help you walk through there. And I'll try to make it not too long, maybe 10 minutes where you could kind of walk through an example with me, get used to looking at your window, resizing and all that kind of stuff. And then focusing not so much on trying to memorize the key steps, but being able to look at your calculator and figure out if I need to do this, what do I do next? Okay. Let's see. So now let's take a look at these. Again, we'll go a little bit quicker. So we purchased a house for $210,000, and then we're going to use function notation to write formulas for the value of the house in dollars X years after purchase. Okay. So if we increase by $1,500 per year, is that exponential or linear? And how do we know the difference? Why?
It's linear.
Why?
because it's a set amount each year.
Yeah.
It's an amount, not a percent. So so the difference is a percent will be exponential, an amount will be linear. Okay, so that's kind of good. Yeah, it's not necessarily, so this is a linear process. So again, the way we think of this is really y equals mx plus b. So we have a starting value of 210,000. We'll put v of x, and we're going to increase by 1,500 x, and x is the number of years. So each year it goes up by 1,500. So that's a linear process. 1,500x plus 210,000. So far, so good. So that's, and again, I don't think I put much of that on the test because it's, that's linear. We tested you under linear, that's fine. But then how is it different when we have a 30% per year? That's exponential, right? Because it's a percentage. What do we do when we have the rate of increase to get to the base? Eventually, I don't like to do it at the first step. What do we do first?
A, B.
Remember, when we have the rate, we add 100%. So I like to add 100% first and then divide by 100 to turn it to a decimal. Now you could do it first and then deal with the decimals, but I like to just add. Remember, we've got a rate. This is the rate. I add 100%. So 130% is where I'm going to get my base from. I divide by the 100, and that will give me my base is b equals 1.3, or 1.30 if you want. Okay, so that's what the base is. And then what's our starting value? Same thing, it's the 210,000. So we write our function. The value of the house in year X is equal to 210,000 times 1.3 raised to the x. So 30% increase, 0.3, but remember we always have that 100. We get the value we started with back plus 30% more. Good investment. Okay, so far so good. Okay, I'm going to look at this next one. Within a context, it's decreasing by 15%. So again, we've got the rate. How do we get to the base? We add 100.
To a negative.
Good. To the negative 15%. So it's 100 here, but we make the rate negative. And that, so then it's 100 plus a negative 15. So it's really subtraction. It's what, like 85%? And then again, we divide by 100 to turn it into a decimal, because the decimal is what we're eventually going to use. So our base is 0.85. We use the same format. V of x equals 210,000. And this time our base is 0.85. And we raise it to the x. Now after you get down with this, you may just jump to that 0.85. You say, 15% decrease, that's a 0.85. You don't necessarily have to show all this in between work. I'm just doing it to show you, if we have the rate, we will always add 100. And if you go with that each time, it helps, because once you start seeing that there really is a systematic way to go through a problem, and you get the system down, and then you deal with the things that are a little bit different each time. So we dealt with that. Remains constant, does not change. This sometimes is the hardest one to come up with, but does not change. Actually, it is a function, but there's no place for the input. That's what makes this thing hard, right? V of x equals what?
0.
1.
Well, how much is the house going to be worth if it never changes in value?
Same.
It's going to be 210,000 because that's what it's worth. If it never changes, bless you, there is no place to put the x, because the x really doesn't matter. 10 years down the road, it's still 210,000. So it's kind of the hardest one. So the constant function is really just y equals a number. And in this case, a 210. So it doesn't feel like a function because there's no x in
Get
there.
it confused with the
Vertical, exactly. And that's the other part we figure, yeah. So the vertical line is, there is no function there, right. But this is a horizontal line. Okay. And again, these are the types, this is just applying what we learned. Again, we're adding 100 or we're subtracting 100 depending upon what kind of information we add. That's really all there is to it. And then we're working with either decimals or percentages, and you figure out which one you want to work with. If you want to work with decimals, then instead of 100%, you work with 1. I don't like and in teaching, I find that trying to teach add or subtract 1 is very confusing to most people. But adding or subtracting 100% seems to make sense. Because 1 is a number, and we change what 1 is, right? We change what the 100% is. But 100% isn't really a fixed value. It's just, it has this idea of being everything that we started with, which is really what it is. Okay, good. Let's take another picture. There we are. Page 6. More practice with those. That's good. Here's some worked examples. And again, you're welcome to watch how they do it. Again, they might do some things a little bit different. And you can already see down here, they're taking the base as 1 plus 0.3, so they're not dealing with 100%. I take the 30%, add 100%. I like to work with percentages. So, but you know, maybe it makes sense once you just look, it's a different way. And I find that it's oftentimes helpful to look at different ways of doing things, but maybe not at the beginning, you know, once you get things down. So I would say, you know, stick. And then we're in the doubling time and halftime. And what did I say about doubling time and halftime? We don't need it. We might need it, but it'll become, we don't need it for the test, certainly. And you'll see that it really isn't anything different. I'll show you the method, but I'll show you it's kind of, because here's the deal. We do it a little bit different in math class. Where you're going to apply it is most likely in a chemistry class, sometimes physics, but mostly chemistry, because it's dealing with processes that are exponential, a percentage increase, decrease. They do it differently in chemistry than we teach you to do it in math. Isn't that kind of whacked? You use it in chemistry, but the math teachers teach you a different way to do it. In chemistry, they use factors and they just go with it. I'll show you a little bit so it's easier to understand. Again, after we've taken the test, the stress is off. We'll come back from spring break. I'll show you a few of these. It'll make sense and you'll be just fine. Because when you double something, what do you do? Add what?
You double it. It's the same number.
Yeah, you add it to itself or you multiply it by 2. So that's good. So it's either multiplying by 2 or adding it to itself, right? That's how we double. And that's all it is you take what you start with, you get whatever the double is, and you figure the time. And the reason these two concepts are there is because that's what becomes constant when you have something exponential for a particular interest rate, particular rate, is the amount of time it takes to double is what's constant. So if it takes 7 years to double, it will take another 7 years to double again, to quadruple. And then to become 8 times bigger, it'll take another 7 years. So that's one of the reasons they use it, because it gives them, it makes the analysis of exponentials closer to being like linear. You can just talk about every 7 years it's going to double. The same thing now, what about half-life? So if you multiply by 2 to double something, how do you get half of what you started with? You divide by 2. Okay, and that only works when things are decaying. So you just take half of what you started with and you figure out how long does that take. If that takes 5 years, then every 5 years you will have half of what you started with. So that's the conceptually, that's what's important, and it's something that you understand. But then when we get into the mathematics of it, it throws in a murkiness to things. So I prefer that at this point we focus on adding 100 and subtracting 100, and we've got the initial value down. So when you first learn to juggle, you only want a couple balls. In fact, you start juggling. What's what? One ball. Maybe you don't call that juggling, but and then you maybe put in 2 balls. That's about as far as I want to go. Some people put in 3, but so the fewer things you're juggling, the better you become at it. And then then you throw in some other things, and maybe you start anyone juggle? I had one of my students was a really good juggler. In fact, he actually taught the class once, so it was kind of cool because I mentioned about juggling. But it's just there's this technique that you get down, and then it's not hard. And he was able to show us. He made it look easy, but it was his practice. Have to practice, and then there's this technique. The problem is when you're juggling, you're trying to watch all 3 balls at the same time, and he says you don't do that. But you start, and as he says, you start with 2 balls, get that down, and then you add that 3rd one in there, and it all works. Okay. So let's see, how about, they've got, within the book they do have examples of how to do things. And again, if you want to cut and paste these into your notes, that's fine too. Because again, at the beginning they're kind of helpful. Let's see, what was this one for? This is a worked example, so they're going to work through it. Let's do this. Here's a media example that they will show you. So there must be a you try. How about we do this you try together? Okay. What I'm going to do, if I can, let's see. Let's move that up. Let's move this up. Get this all on the same screen at the same time. Okay, so we've got this table of values. Let's see if I can get the calculator to behave this time. Oh, here it comes. It's just slow. Okay. And I think I found a way to do it. I move it here. And then what did I do? Oh, I know. I changed the model. There we go. And I change it back. Seems to work. Okay. So these are typically a little bit easier. Oh, shoot. Try one more thing. There we go. Okay, so we'll mirror the displays. There we go. the screen. So what we're asked to do is, here's our data, and we're told that this is exponential. I know I'm kind of hiding part of it. Use your calculator and steps for exponential regression to generate an exponential function model for the table below. It looks like the table's above, but we'll forgive them for that. Round A to 2 decimal places and B to 3 decimal places. So there will be one question on the test that'll have you go through exponential regression. And again, what I kind of try to focus on is what are the steps that we go through to make that happen. So whenever we want to do regression, we always go to the stat button, and this menu comes up. So just get used to the stat button. And again, I find it better if you don't try to memorize the steps, but you remember, okay, stat, edit, stat, calc. Okay, so stat, edit, here we are. And what we're going to do is we're going to edit. So we just hit enter. This has remembered a set of data that's been put in here. Does anyone remember how do we clear this out? Up until the L1 is chose, you hit clear and then enter. So you just get used to this. And the thing is you have to do it a few times. Even if you have it in your notes, if you haven't physically done it, your body will forget. Your muscle memory, if you're any athletes or any muscle memory, not everything's up in your head. There's a lot of things that are throughout our body, so you have to do it. And then we start putting in our numbers. So list 1 is all the x's, so we've got 0, 3, 5, 10, 15, so we start putting those in. 0, enter, 3, enter, 5, enter, 10, enter, 15, enter, and 22, enter. And then we arrow over to get into our list 2. And then we put all our y values in. Let's see if I can get this to... Here we go. Okay, so we've got 4.63, 4.63, enter, 5.92, and people ask, do I really have to put these all in here? What do you think? Yes, because if you leave one out, the regression will be different because it doesn't have all the information. It's just like, leave one piece of information. Well, they didn't tell me my house was on a floodplain. You think that's kind of important? Every year your house is going to get flooded. That would be nice to know. So you can't just leave pieces of information out. Especially important stuff like that. And then 26.39. So that's the part. Again, isn't this exactly what we did in the first set when we were doing linear? So far, nothing different. We just entered the date. And again, we'll do this with when we get to quadratics. We'll also do quadratic regression. Same thing, except the only thing that's going to change is when we go over back to stat. So we go to stat. This time, remember, we go over to calc. And this time, we're not doing linear regression. We're doing exponential. So what do we do? It's 0. I'm going to arrow down to it. Oops, what did I do? Stat, calc, and go all the way down to 0, which is actually 10, but that's where it is. It's exponential regression. You have to go down far enough. And then you hit enter. Again, if you've got a TI-82, that's actually, you hit enter again, or an 83. These 84s, you just have to keep hitting enter until it calculates. Take all the defaults, and it should just work just fine. Maybe I have to hit one more time. There it is. And then it gives us our equation. And this is what we're looking for. Okay. They want us to take it, though, and they want us to round A to 2 decimal places. So we would say the equation is, now, what we're going to write is v of x. Still trying to get comfortable writing. So we'll say v of x. Again, initial values here, this is our a. They wanted to round it to 2 decimal places, so that's 4.64. And then this is our base. Can anyone tell me, is this increasing or decreasing? By how much?
8%.
About 8%. Good. 8.22% if you want to really be, but yes. I think my battery must be getting low. This keeps going out on me. There we go. So then, but we put in the 1.082 because they wanted to round it to 3 decimal places, and there's our x. Okay. On the test, that's the same thing. You're just going to, I'll give you some data. You just need to do the regression. Give me the equation. I don't ask you to do the scatter plot on this one. We could do that because we've got everything, but this is the main, we just need to come up with the equations. Then once we have an equation, we can do everything else we need to do with it. And like we said, one of the things is, we see, well, that's an 8.2% increase. Okay, we're starting at about 4.64, and then we're increasing. So we, and we saw that in the data as we were putting it, the values were getting bigger. Okay, so we knew it was an increase, and it all comes out just fine. Okay. Again, this is very advanced technology, actually. When I was going to school, back in the 80s, we would only do linear regression, and we used all these formulas because they didn't have it built into calculators at that time. We never were able to do exponential regression because the formulas for this, I don't even know if there's formulas, but it's the same sort of process, but it's a lot more complicated. So we never used to do that kind of stuff. But now you can do it as a regular part, and really it isn't anything different than doing linear regression. You put the data in, you just choose, give me a different type of equation. And the thing is if we came back over here, so let me take a picture of this while we're at it. Okay, if we would have, and then I'll clear it out, we could have asked for number 4, which is linear regression. Could have gone through all the steps, and if we weren't paying close attention, we might have thought, oh, there's A and there's B, and just write it down. But is this going to give us right answers? No. This is a totally different process. It's assuming linear, not exponential. You just got to be careful, but hopefully you can look and say, well, that's linear, that's not exponential. They wanted exponential. And I can see that it's a linear equation. It's not an exponential, so it doesn't, don't put this and this and then put an exponent on it. This is the type of equation it is. But it will give you each of the types. So you've got to be careful about when you go to do it that you're doing the right kind of regression. And it's not too bad because I'm not going to ask you to do linear on this test. I'm only going to ask you to do exponential. I already tested you on linear. When we do quadratics, I won't ask you to do either of these two. We'll just say it's quadratic. I think on the final, I'll take a look. They do ask for one because we do kind of put it together. And when you're doing 150, you put it a little bit. Sometimes they'll give you a set of data and they'll say what kind of regression is best for this. And so then you put it in and you look at the points and you look at the overall shape. Is it a straight line? Is it a U-shaped thing, or is it a kind of a J curve? And then you'll know whether linear, exponential, or quadratic. But that's kind of, if you can do that part. And then, again, I'll make up some videos doing a few examples, how to use a table, how to size your window, and I'll be doing it actually using some of those examples from the practice test. I'll work through them so that you'll also, in doing that, you'll pick up a few things. Because one of the equations has e to the x, and I'll show you how to do that. Well, maybe I'll show you right now, because so let me do this. Let me clear this one out. So yeah, we got a few minutes, so we'll just do this one. So I'm going to make up a problem here. So let me shrink this one down and get rid of it. So what I'm going to do is, there's something like, and this might not be exact, but it'll be close enough. I give you an equation like 3e to the x equals 17. and I ask you to solve for x. How do we do it? We take the left-hand side, we put that into the calculator as y1, and we take the right-hand side, we put that in the calculator as y2. Or either way, the order doesn't really matter. Okay, but we're going to graph basically the left side and the right side. And where's our answer going to be? Where they intersect. Where the left is equal to the right is where the intersection will be of those two graphs. Okay, so first trick is I put the 3 in there. That wasn't too hard to find, but where do I find the E? Well, this thing's too small to even see, but there's a button that has LN on it. And if you find the LN button, it's on the left-hand side. I think it's the third from the top, right, LN. What's right above the LN key? You see an E to the X. So you have to do second LN, and there's your E. Okay, second LN, and then, but it doesn't give you the X, it just gives you E to some exponent, and that's where you have to put the exponent X. Okay. So far, so good. Anyone else? You doing okay? If you get stuck, this is a good place to get you unstuck, because otherwise you won't go anywhere. Okay, so that's all we got to do for that side. This other side's real easy. It's just y equals 17. And what do we call y equals 17? It's a constant function, right? What we're expecting to see is a horizontal line at 17. Hopefully we are. Okay. I'm going to go to the zoom standard because I don't know what kind of window I have, just to show you something. I see the exponential part, but do I see the y equals 17? Why not?
Because you're at standard and it only goes to 10.
I only go up to 10. I can't see 17 if I don't roll my window up a little higher or something, however you want to call it. So what I do to get that is I just go to the window. Now the window, let me just come back to my marker here. On the window, there's only 4 parts that are really important. There's your x max min and x max, your y min and y max. Ignore everything else, please. They can do things, I know they will, and they're kind of fun to play with, but I've gotten through them all my life without ever messing with them, because I just don't want to do it. Some students will come back and say, yeah, that's cool. But anyway, those are the 4 things, and they're the size of your window, right? So y max, if I want to see more of a top, I need to make the y max bigger than 10. And since I know it's going to, wherever the intersection is going to be, it's going to be at least y equals 17. So what would it make sense to go to? 20 would be great. 25. 150. That might be too much, but anything more than 17. But 15 wouldn't do it, would it? 16 won't do it. 16.9 won't do it. 17 sort of does it, but it does, again, 20 is, yeah, 20 is the best. So now that I'm here, again, I just arrow down, I think, yeah, arrow down to the y max. Let's just change that 10 to 20. Not just 2, but 20. Okay, so let's clear out the window. And then now when I go back to the graph, look what happened. I can see further up, and I see my intersections. And now how do I find that intersection? Above the trace button, you see a blue thing that says calc. That's the graphing tools, the graphing calculation. So I go second calc because it's blue, and I'm going to use number 5, which is the intersect. So you can either arrow down to it and then hit enter, or you can just click on number 5. It's going to ask you 3 questions. The answer to these 3 questions are enter, enter, enter. And again, you could do it with the blindfold at this stage. Later in the class, we're going to go through each of those stages a little slower, but this one, we literally can hit enter, enter, enter. So it's asking for the first curve. It's on the exponential. Yes, that is our first curve, so we hit enter. It asks for the second curve. It has jumped to the line, and yes, that is our second curve. We hit enter. It asks us for a guess, and we say, I paid $150 for a you guess. So you just hit enter, and it does. It's fast. We're going to see later on, we'll take that guess step, and we actually will move it around because there's some, we're going to get with functions that it might cause us problems. We won't get our answer unless we move it to the right place. These are really simple functions, and it handles it. So you can really, literally, as long as you can see it, enter, enter, enter. It tells you your answer. And so notice the y is 17. The intersection is x equals 1.73. And I erased my equation, but let's see if I can remember what we had. It was what? Something like 3e to the x equals 17. And I just solved that. X equals 1.735. I'll do it to 3 decimal places. And that's all I got to do. I'm going to show you one last step since we have just a little bit of time. We can actually check this to make sure it works. And what I'm going to do is I'm going to, let's see, hit clear. I'm back at the home screen. I'm going to take 3 second natural log, so 3 to the 3e, and instead of putting the x, I'm going to put in the answer, 1.735. When I hit enter, what do you think I'm going to get? Close, but a little overshot because I rounded, right? I rounded up, so I'm a little above slightly. But if I round this to 2 decimal, 1, so yeah, pretty close to 17. And that's what you'll find with exponentials. It's very critical on the decimals. So you want probably usually at least 3 decimal places. And actually, depending upon what you're doing, you might want 5 places in the exponent because it can make a difference, especially if this is billions of dollars. 600. This was billions of dollars. That's still $6 million. So that's an error of $6 million. I don't know about you, but that's a big error for me. I'd miss $6 million. Never seen $6 million, but some people maybe that's nothing. But, so again, if you need accuracy, real accuracy you'll get with like 5 decimal places, but that exponent is very powerful, and a little change in the exponent will do it. But this is a way, doesn't it feel kind of satisfying? We were able to graph this thing, we find the answer, and then when we plug it in, we pretty much got what we were expecting. And so you could do that. So that's basically all this test will be about, is few equations just like this one. All you got to do is graph both sides, find that intersection. You got your answer. Know what the starting value is, the initial value. That's the number in front of the equation. Be able to find a rate. If I give you a base, find a rate. If I give you a rate, find a base. So be able to add 100 or subtract 100, but know when to do which, right? And when I got a decay, that's a negative rate. An increase is a positive rate, and you'll be all good to go. And just practice, practice, practice. And be able to do the exponential regression. And those are the whole things that we'll do for this one. And you'll see that as we keep going, it becomes more and more compact. This is just a few things we do for each of the next tests. And that's why the first test is really the hardest one, because there was so many different things we were doing. And again, there'll still be that opportunity to take a retake or a makeup test for that. We'll worry about that next week. Okay, thank you. We'll see if we're still live streaming. I don't know if I left these people behind. Let's see.
Do you want to do the word of the day?
Oh, yeah, that's probably a good idea.
We didn't do it last time.
We didn't either, so how about we do like a phrase of the day? We came up with this, I don't know. What should we do for our, what's a good word of the day?
Calculator.
Calculator. Sure.
On the Math AS,
Do we get points for doing the homework?
They were not
Yes and no. Yes, if you do the homework, then there's so many points attached from this. Like,
I didn't just have one video for us to
or something.
There was.
But if you do the test and you do 100% or 90% or above on the test, I'll give you points. So what I'm focusing on is, are you, if you do well on the test, you learn it. So I want you to focus on learning. But also, if you do the homework and you don't do so well on the test, then those points are coming out.
Okay, so you get points for doing the homework. Yes. And you get points for taking the test, getting a 90%.
Right. And so if you don't do the homework but you do well on the test, I'll give you the homework points anyway. But if you don't do well on the test, then you definitely want those
Homework points. Okay.
And what I find is people who do the homework typically will do well on the test, so it kind of works.
Okay.
Yeah, and you can come up with.
Well, I was doing the mini lessons, and then I feel like I looked like I was missing points. I just like the mini lessons because I don't have to watch all the videos, but.
So basically, it told us that we had to do the homework or the quiz.
Right.
But we don't have to do both of them.
No.
Oh, okay.
Yeah.
I've been displaying my homework.
Yeah,
That's
fine.
cool.
As long as you're learning,
Yeah.
and again, it'll show up on the test, and then
And
that's
she
not
was like,
an issue.
nobody else class.
But yeah, I look at your homework. If you've been doing the mini lessons, but going through them yourself.
It's just because I like
State
the
code.
book.
Sure. I
Was
can
nobody
practice.
here that
So
day?
if you've done
No,
it,
it's fine.
I'm open any way that you're going through
Oh my
learning
gosh,
it.
I
It's
just
fine.
happened to be like,
Okay.
so for this single
My
exam
class-
is 4 and 5, right? That I
Yes,
have before
just
this
4 and
class, the
I'm
teacher
You mentioned the
yelled at me.
decimals as to
So I had
why,
a class, and I
Yeah.
was like,
how
I'm
many
not sticking around
decimals
school for
was
2
very,
hours.
because I'm just like,
I'm teasing out.
why?
So I went
Why
home
sometimes
and
2, why sometimes 3? You know, like, when do we just pick however many decimals?
Yes.
So that is
It happens every time.
Good. Good.
Just want to stick around campus.
Okay. Let's check. I think we're still live streaming, so we've been talking to the world. That's okay.
Mr. Little Crow, I got an email about the honors